Hello everyone. Welcome back to Dr. Lu's VCE Chemistry channel. Today, let's learn together about the 2019 VCE Chemistry examination. We will focus on questions related to volumetric and chromatographic analysis. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Yes, precise results may be biased because even though they are close together, they may have been obtained from a preferred sample and not reflect the true characteristics of the substance under analysis. Sensitive instruments should give more accurate measurements but may be subject to random errors associated with environmental fluctuations. The method must be appropriate for the analysis to be valid. Repeating a procedure using the same equipment will not remove the uncertainty associated with systematic errors. Systematic errors are consistent repeatable errors associated with faulty equipment, experimental methods, or design flaws. The vitamin C is titrated by standard iodine solution. Vitamin C is in a conical flask, and the standard iodine solution is in a burette. The key word is underestimation. The volume of water in the flask does not affect the result of titration. The actual concentration is less than the true value. So, the actual volume of the titrant is larger than its true value. However, we don't know this error and also use labeled value to calculate the concentration of VC, so, the concentration of VC is larger than the true value, and it is overestimated. The initial volume is read as higher than true. So, the volume of titration is less than true. So, concentration VC is less than true and is an underestimation. If the recorded mass was lower than the true value, this would have no effect on the titration data, but since the determination of %mm requires division by a lower than the true number, the calculated concentration of VC will be overestimated. First, calculate the mole of iodine used. Second, calculate the mole of VC. Fourth, calculate the mass of VC. Finally, calculate the percentage mass to mass. HPLC is used to measure the sucrose concentration. The standard cure is given below. The horizontal axis is concentration, and the vertical axis is peak area. The sucrose concentration tested in the HPLC is asked, not in soft drinks. The peak area is measured as 1900, which corresponds to 0.30. Don't forget the units of concentration as grams per liter. The original sample is not directly measured. Before running in HPLC, this sample is diluted from 5 to 100, then from 10 to 250. The 100 milliliters volumetric flask sample is diluted 25 times before HPLC. Its concentration is 25 times HPLC. This concentration is the grams per liter in a 100 milliliters volumetric flask. Using the concentration in a 100 milliliters volumetric flask, we calculate the sucrose mass in the 5 milliliters sample, and final the percentage mass to volume. We know the percentage mass to volume in part A2, so it is easy to calculate the mass of sucrose in 1 can. Identify whether this experiment is valid or not. Only 1 mark is awarded. One of the answers is okay if you think this experiment is valid. The method is valid as data is consistent for standard solutions of different concentrations made up of pure sucrose. The conditions used in the HPLC were consistent across all the standards and the soft drink solution. Peak areas for the standard solutions and the diluted soft drink sample were recorded at the same retention time of sucrose. However, if you think this experiment is not valid, also okay, the method is invalid because not enough points were established from 0 glucose through to 0.80 grams per liter glucose. Explain why some people replace sugar with aspartame with metabolic reactions, glycemic indices, and energy content. Metabolic reactions: sucrose hydrolyzes to glucose and fructose. Aspartame hydrolyzes to phenylalanine, aspartic acid and methanol. Glucose oxidizes in respiration. Glucose undergoes condensation polymerization to form glycogen. Excess glucose from sucrose can be converted to fat, causing weight gain. Glycemic indices. The rapid increase in blood sugar levels from sucrose is due to high GI. Can make it hard to control diabetes due to insulin variations. Aspartame does not raise blood sugar levels since it does not produce glucose. Sucrose is useful where a quick energy burst is required. Aspartame releases energy more slowly via different pathways. Energy content. Aspartame has the same energy content per gram as sucrose but is 180 times as sweet, therefore, significantly less aspartame is required for the same effect. This reduces overall energy intake. Full marks were awarded for a correct point in each category. The differences in metabolic reactions were addressed infrequently, and when they were, misconceptions such as aspartame hydrolysis is faster and hence has a high GI were common. Confusion between energy content and relative sweetness was evident in responses that suggested that because aspartame is sweeter than sucrose and less is used in food, it has a higher energy content. Higher scoring responses identified relative digestion products and linked the lower GI of aspartame with it not releasing glucose as a digestion product. In volumetric and chromatographic analysis, 3 multiple-choice questions are worth 3 marks, and 1 short answer question is worth 8 marks. The overall score for this section is 11 marks. With a total possible score of 120 points, the percentage for this section is 9.1% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.